We're going to start with the inequalities, and then it's got some word problems that are kind of interesting also. But we're going to start with the inequalities. I know that you have done these before, and I know you have a particular strategy for doing them, and it's okay. As long as we end up with the same answer, it's okay. I'm going to be using a different strategy though, because I'm going to approach all of our inequalities using a number line. So even these absolute value ones, I'm going to use a number line for. If you don't like my method, it's cool, but you got to have a method that gets you the right answers, okay? So I think this is really simple. Be open-minded. Let's see if we can figure out what's going on. If I drew a number line, and I put two numbers on the number line, like let's say 5 and 12, and I said to you, what is the distance between those two numbers? Everybody in the room would say 7, right? Not a trick question, 7. And how did you get 7? 12 minus 5? Could you have done 5 minus 12? Yeah, as long as you took the absolute value of it. So when you see an absolute value expression with a minus sign in it, what that's really doing is telling you how far apart two things are on the number line. So if I said, what's the absolute value of 6 minus 8? You'd say 2, but what that means is 6 and 8 are 2 apart on the number line. Okay, that's easy. So what does this say? Because it's an absolute value and a minus. This says that x and 2, here's my number line, here's 2, x and 2 are more than 3 units apart. So here's how you do it. It's so simple. Even if I'm talking gibberish right now and you don't understand a thing I'm saying, watch. Whatever this number is right here, I'm going to start at that point. And I'm going to count forward 3 units. So I'm going to go forward 3, which would put me where? 5. And then I'm going to go backward 3, which would put me at -1. I'm going to put open dots at those 2 points. They're open because that's not or equal to. If that were or equal to, I'd close them in. You are always going to shade either between your 2 dots or outside of your 2 dots. That depends on whether you want this distance to be more than 3 or less than 3. Since that distance, remember, that absolute value of a difference is a distance. That distance has to be more than 3. So where do you think I'll shade if I have to be more than 3 apart? Outside. I have to be past 5, I have to be beyond 5, or before -1. All of these shaded points are more than 3 units away from 2. That's what the problem says. The distance from 2 is more than 3. So you have to be out more than 3 units or back more than 3 units. So your answer is everything less than -1 or everything greater than 5. You don't even really have to do any arithmetic. You just draw it on the number line. So I'm coming over here to this one now. I'm going to do a very similar thing. There's a difference though here. Does anybody see what the difference is? There's kind of a little bit of a problem. What?
Negative.
What's negative? Yes, very good. Solomon says, whoa, whoa, whoa. This is supposed to be a minus sign. We're supposed to be subtracting. Well, can I think of this as x minus -5? So instead of putting a positive 5 on my number line, I'm going to put a negative. This is kind of like your circles. Remember when you found the equation of the circle, you took the opposite of the parentheses? It's like that here. You take the opposite. So when it was x minus 2, I started at 2. When it's x plus 5, I'm going to start at negative 5. Okay? Now I'm going to come out here and I'm going to put a dot. I'm going to come back here and I'm going to put a dot. How far am I going to go to put that dot? 6. So if I go forward 6, I would be at 1. And if I go backward 6, I would be at negative 11. I'm just counting on the number line. Now, see these 2 dots? This time they're going to be colored in. And now I have to shade. You're always going to shade between your dots or outside of your dots. And that depends on whether you want the distance to be more than 6 or less than 6. Well, this time we want it to be less than 6. So we're going to shade in between. And going back to the beginning, can I write my answer like this? What do those brackets mean? Closed dots. Everything between negative 11 and 1. All right, let's come over here. Uh-oh, this one's a little bit different. What's different about this one? There's a 2 in there, coefficient. All right, now wait a minute. What do you think I'm going to do with that 2? This might be a little scary to you, but it's perfectly legal. We're going to divide it out. We're going to divide everything by 2. Wait, Miss Ford, can you do that? Miss Ford does not do illegal things. Yes, you can do that. Divide everything. Get rid of that coefficient. So now our problem looks like this. And you might want to think about that as 3.5. It's up to you. Doesn't matter. Whatever you're most comfortable with. Okay, so what am I going to start with? What number is going to be right here in the middle of the number line? Positive 4. There's going to be a dot out here and a dot back here. And I'm going to find those dots by counting this much. Yeah. So if I count ahead 3.5, where would I be? 7.5. If I count back 3.5, where would I be? Just 1/2, wouldn't I? If I counted back 3.5. Filled in or solid? Oh, did I say filled in or solid? Yeah. Filled in or open? You're filled in, right? Filled in and solid. We're going to shade out this time. Remember, you always shade in between the dots or outside the dots. Where are we going to shade it? Outside. Why are we shading outside? It's greater than. Greater than means you want to be farther away. And where you're farther away is out here and out here. So our answer is everything less than or equal to 0.5 or everything greater than or equal to 7.5. There's one more. Let me see. Maybe there's more than that. Let's see. I think there's just one more of those. Yep. One more. Oh my goodness. Anything bother you about this one? It appears to me to be backwards. Would you agree? Yeah. Now, I want you to just stop and think a minute. I just erased it. But if I did 6 minus 8 or 8 minus 6, does it matter if I have it in absolute value?
No.
Aren't these exactly the same thing?
Yes.
So if I don't like the order that that one's in, I'm just going to turn it around. You are allowed to do that. It is exactly the same thing. As long as you're taking the absolute value, you can switch your subtraction around. Lauren? See, 6 minus 8 is exactly the same as 8 minus 6, as long as I'm inside absolute value. So instead of subtracting 3 minus 4x, I'm going to do 4x minus 3. Then I'm going to do what I did down there, which is I'm going to divide everything by 4. Now I know it's got fractions. It's going to have fractions no matter how you solve it though. So you're just going to have to deal with it. What number am I going to put in the middle of my number line? Positive 3/4, the opposite of this guy, so it's positive 3/4. Then I know I'll have a dot out here and a dot out here. And I figure out those dots by counting back and forth. And how far am I going to count? 9/4. So if I start at 3/4 and add 9/4, where would I be? 12/4, which I might as well say 3. And then if I start at 3/4 and subtract 9/4, negative 6/4, which I'll want to reduce to negative 3/2. So here are where my dots are now in reduced form. Open dots or closed dots? Open. Shaded between the dots or outside the dots? Watch it. What's less than mean? Less than means closer, means inside. So we're going to shade in between the dots this time. So we can write our answer like this one, except instead of brackets, we'll use parentheses. So we're going to switch gears here in a second. Before we do, when you have an absolute value inequality, draw a number line, and right in the middle of your number line, put the opposite of this number. So in this case, you put a negative 4, right? Then you're going to put a dot out here and a dot out here, a dot on either side. And you're going to figure out where those dots are by counting forward 6 and backward 6. So negative 4 plus 6, negative 4 minus 6. And then you shade. If it's a less than problem, you shade inside the dots. If it's a greater than problem, you shade outside the dots. So this one would be shaded outside and those would be filled in. Got the hang of that? It's pretty easy, but you've never done it before probably, that way. All right, so let's see the next kind of inequality that we have. The next kind looks different. This is not an absolute value, so this is a different problem. Take a wild guess of what I'm going to do to start. Oh, well, I'm hearing some great ideas. For purposes of doing the inequality, everything you said would be fine, but for purposes of doing the inequality, it's going to be easier to factor it. It's going to be easier to factor it. everything you said will work. So if you want to complete the square, that is hunky-dory. It's a little problematic with the inequality, but we can work around that. Try to factor. I promise every one of these that I give you will be factorable, and that's the easiest thing to do. They get a little challenging otherwise. So how does this guy factor? -5 plus 1. Remember, if you are wondering about that, you can do a quick FOIL. If you FOIL it back, it should be with this, right? And it does, so you're right. Now I'm going to draw a number line. I said all my inequalities are going to be done on a number line. This time, I'm going to start with 2 dots on my number line. Take a wild guess where those 2 dots are going to be. Negative, no, actually, +5 and -1. We're sticking with the theme of doing the opposite, the additive inverse. We're sticking with that theme. Whether it's inside absolute value or inside parentheses, we're going with the opposite. Now, when you put them on the number line, make sure you put them in the right order. -1 has to come first. This is a number line after all. So -1 has to come first. Would those be open dots or closed dots? Those are open dots, right? So now we got to figure out where to shade. Don't you look like you're going to the office today? Don't laugh. All right, so now all I need to figure out is where to shade, okay? Now, you guys, I want you to think about how we did it in our absolute value problems. When we had 2 dots in our absolute value problems. When it was a greater than, where did we shade? Outside. When it was a less than, we shaded in between. As long as there are just 2 dots, that's how you do it. So this is a greater than, so where am I going to shade? Outside. So I'm going to shade out here, and I'm going to shade out here. So my answer is x is less than -1 or x is greater than 5. If we have more than 2 dots, then we are going to have a different strategy. But as long as we only have 2 dots, which is what we have in most of our problems, then less than means between and greater than means out. That's it. All right, let's look at the next one. Okay, you can probably do this one all by yourselves. What's the first step? Mamuna? Factor. And can you factor that? Do you know how that factors? Remember, whatever you put up here has to multiply to give you 10. And add to give you 9. Take a guess. Well, if you get it wrong, you get it wrong, but we got to do something. So just take a wild guess. We'll fix it. Okay, let's try +9 and -1. So that's her guess. Now we're going to check it by foiling. Mamuna, look. When I foil, first times first, outsides, insides, last. Now we have a huge problem. See that right there? What's that supposed to be? A 10. So 9 times 1 doesn't give me 10. So maybe I should change this to a 10. Now I'll at least have the right last number, right? Now what about the middle number? This is going to be a 10x. Does that add up to give me the 9 that I want right there? There it is. There are your factors. Okay? I'm old and I do this for a living and I still guess when I factor. So guess and just check it out and see, and pretty soon you'll get it right. So where are my dots going to be on my number line then?
-1.
There, where are they going to be?
1 and -10.
Yeah, -10 and +1. Remember, the the dots on the number line go at the opposite of the parentheses. Those dots this time are going to be solid. And where will I shade this time? Okay, we got to get this figured out. Less than means less than, little, in between. Greater than means big, right? Out. So this is a less than problem, so it's going to be shaded in between. And I can write my answer as an interval. When you're in between, that's the easiest way to do it. And that's it. All right, let's try the next one. All right, Jacob, you on the right page with us here?
Yeah.
All right. Can you factor the next problem for us? How does this factor?
It has to multiply to get 10 and then add up to 3, right?
Yep. Multiply
So
to get -10.
negative 2 and negative 5. Oh, no, not -5, but +5.
All right, so his thought process was, I gotta multiply and get -10. So he knew one of them had to be positive and one had to be negative, right? They couldn't both be negative because then he would have gotten +10. All right, so let's do a quick check here. He's gonna have x squared plus 5x minus 2x minus 10. That's easy. Gotta switch the signs?
Yeah.
Because he's got everything right, but his 3 here is gonna be positive. So this is gonna be plus and this is gonna be minus. Everybody good with that logic?
Yeah.
So now I'll draw my number line. And on the number line are gonna go 2 dots, and the 2 dots are gonna go at the opposite of the parentheses. So -2 and 5. They're gonna be open dots, right? And they're gonna be shaded less than. Less than means littler than, right? Inside, we don't want, this would be big, this would be little, so less than in here. So our answer is -2 to 5. And I'm using parentheses because the dots are open. Liam, you paying attention? All right, would you try this one on your own? See what you can do with this one. And then you get it factored, and then put it on your number line. What's going through your head? What multiplies to give me 6, but adds up to give me 5? Jacob?
2 and 3.
So 2 and 3 plus 2 plus 3. How does that look, everybody? Does that seem about right? And of course, if I have doubt, I just FOIL it and make sure I get x squared plus 5x plus 6. All right, so then you do your number line, hopefully. You put 2 dots on the number line and you colored them in. And where did you put those 2 dots?
-3 and
-3 and -2, and they have to be in this order, guys. They have to be in that order, because if you had the whole number line going, isn't that the order they'd be on the whole number line? So that's how you gotta put them on there. Where's it shaded? Outside, the big parts out here. So our answer is everything less than or equal to -3, or everything greater than or equal to -2. David?
I have a question, like when you use, sometimes you can use the brackets and sometimes you write it like that. Oh, can you only use the brackets when it goes inside?
Well, that's when it's easiest to use the brackets. You can use the brackets and parentheses here, but remember, these are the ones that require us to use infinities. So if I use my interval notation here, it would look like this.
Oh, okay.
And it's easy to write this. It's a little more awkward to write all this. But if you want to, you can. That's what it would look like.
Alright, but I'm like when it goes inside, that's when you use brackets.
That's when it's easiest to use your interval notation, right?
Yeah.
Okay, now we've got this problem. Now what's different about this? Well, it's got a cube, so this is a little bit bigger degree, but the rules are the same. We still have to factor it. So take a look at it. How do you think we might factor it, Jacob?
Don't we pull out one of the x's?
So we're going to take out the GCF. We always take out the GCF. In this case, it's x. So we'll take out an x. And we're left with this. Now, that can factor, right? Well, I'm telling you it can. Can you figure out how? Can you figure out how to factor that? Just think about it for a second. Don't shout anything out. You're trying to factor this, so you need 2 numbers that times to 8, but add to -2. So what do you think? Ramuna? She says x minus 4, x plus 2. What do you think? I think she's got it. But if I'm at all doubtful, I'm going to FOIL and make sure that I get this. All right, now the rules of the game are about to change, because now on my number line, I have 3 dots. And when we have 3 dots, figuring out where to shade is a tad more complicated. Remember, as long as you only have 2 dots, you're going to shade in between them or outside them, right? But as soon as you have 3 dots, things change. So where will the dots be, first of all? Let's get the dots labeled. Where will they be?
-2 will be on the left, then 0 will be on the middle, and 4 on the right.
Bingo. So I think everybody gets the 4 and the -2, but when there's a plain X, that goes on as a 0. Okay? Anytime you have a plain X, it's plotted as 0. Okay? Now, these are all open dots, correct? And I have to figure out where to shade. So what you're going to do is pick any number other than these. So you can't pick -2, 0, or 4. Pick any other number. So Shepherd's pick it. Pick a number, any number. 3. So he has picked a number right in here. The number 3 is in there, right? We're going to figure out whether we're going to shade this area or not. And we're gonna figure it out by putting in the number 3 into the equation. So we would have 3 times negative 1, 3 minus 4, times 5, 3 plus 2. So you pick whatever number you want, doesn't matter, he picked 3, that's fine, any number, and you plug it into your factors. Now what is 3 times negative 1 times 5? These are times each other. This is negative 15. Is negative 15 bigger than 0? No. So that means he picked a number that's not, it doesn't work, so we don't shade it. You shade the answers. This didn't work. Okay? Now here's the good news. Even though I can't give you a general rule to tell you where to shade, I can tell you that the sections of the graph alternate in their shading. So what I mean is, if this section between these 2 dots is not shaded, and it's not shaded because that number didn't work. If that one's not shaded, this one out here will be shaded. If this one's not shaded, this one will be, and this one won't be. They alternate. So you have to pick one section and figure out if it's shaded or not. He picked this section and it wasn't shaded. So that means that one is, and that one is, and that one isn't. Now, let's say, Will, had I called on you, what number would you have picked? 5. He would have picked 5. So here's Will's number line. And he picked 5, which is out here, right? You gotta pay attention to where your number is. His is out here. Now when he put 5 in, he got 5 times 1 times 7. 5 times 1 times 7 is 35. Is 35 bigger than 0? So Will would have shaded this section because his number worked. Then he wouldn't shade this one. He would shade this one and he wouldn't shade that one. Do you see how we're going to get the same answer?
Yeah.
No matter what number you pick. So what is the answer? I got to write an answer now. So it's everything in between negative 2 and 0, or everything greater than 4. It's an or. Always an or. You're either here or you're here. Now you could also write that answer like this. The or gets written as a union symbol when you're using interval notation. The or gets translated in the back. Now, we don't mix and match these. So in other words, we don't put this and this. We either write it all like that, or we write it all like this. But either way is fine. Okay, well there's another one of those. Let's give it a shot. Start out by factoring. Anybody see how to factor this one? Take out an X. Sure, we always want to take out the GCF for sure. What about that? That's kind of special. Yeah, how do we factor x squared minus 1? It's called the difference of squares. Do you remember how to factor the difference of squares? Lauren? It's exactly right. It's x plus 1, x minus 1 in either order. Doesn't make any difference. So if you had had x squared minus 16, that would be x plus 4, x minus 4. You guys got to remember that. You've done that a ton. Factoring the difference of squares. maybe you memorized it as a squared minus b squared is a plus b, a minus b. But that's how that works, the difference of squares. So we're factoring. Where are the dots on the number line this time? In order, -1, 0, and 1. And notice I colored them in. Everybody catch that because of the or equal to? Now you don't have any rules here to tell you how to shade. You're going to have to figure it out. And we're going to figure it out by picking a number. Any number except these. You can't pick a number where you have a dot. You got to pick a number in between somewhere. So what number do you want to try, Tessa? 2. Now pay attention. She picked 2, so she's out here. So we're going to see if we shade out there or not. So here we go. We put in 2. We have 2, 3, and 1. If we put in 2 for all the x's, we have 2 times 3 times 1, which is 6. Is 6 less than or equal to 0? No. So Tessa is not going to shade here, which means she is going to shade here. She isn't shading here, but she is shading out here. So her answer is everything less than or equal to -1, or everything between 0 and 1. So we're going to write our answer that way. For some of you, that's going to be the hardest part, is writing the answer. Or if you want to use intervals, you can write it this way. That way will work also. Remember, instead of the or, if we're using our symbols, we use a union. A right side up U.
So why isn't 0 on the answer greater than or equal to like x less than or equal to 1? Yeah. Because since the 0 is going to the right, since it's like going in between the line.
Okay, you're thinking it should look like this,
Yeah.
and then what would this one be?
Less than 1.
Okay, all right, let's just talk about what that says. I understand where that's coming from, but let's just think about what that says. This part of it says x is less than or equal to 1, and that is true, right? X is less than 1. That part I have no issue with, that's correct. What does this say? 0 is greater than x, which means x is less than 0. Is x less than 0? No, x is greater than 0. When you write a compound inequality like this, the symbols are always less than. Always. They're never going to be anything but less than when you have shaded in between two numbers like that.
Thank you.
Uh-huh. All right, so here's what we're going to do right now. I'm going to put 2 problems on the board, and you're going to do them either at the board or at your seats, okay? So here are the 2 we're going to do. We're going to do one of each kind. An absolute value and a factoring problem. All right, so everybody, you can do it on the desk, you can find a corner of your notes, you can do it on a scrap piece of paper, but I want everybody doing these 2 problems, and I need a couple of you to do it at the board.